All right, hi, hello, welcome to the next unit, Unit 4. We're going to talk about complex numbers. So this lesson I will learn how to find the complex number I. So I stands, those are imaginary numbers. Yes, that time has come. We're in math class. You're talking about imaginary numbers. You're going to learn how to simplify complex numbers. You're going to use the fact that I squared equals -1 and the commutative and associative and distributive properties to add, subtract, and multiply complex numbers. So that part you've already done before. We've already learned how to add, subtract, and multiply numbers. Now we're just going to add in what would we do if we had imaginary numbers. Okay, so we have real numbers, or any number that can be written as a whole number, a decimal, and a fraction. Complex numbers are any numbers that can be written in the form a plus bi. Both a and b can be 0. Now imaginary numbers, this is where it's different. It's written in the form a plus bi, but a and b are real numbers, and b cannot be 0. So you have to have that I in there for it to be imaginary. Alright, so the first thing we have to say is determine if the following are imaginary, complex, or both. So this one, so we're looking for, remember, complex is a plus bi, where a and b can equal 0, where imaginary is a plus bi and b cannot equal 0. That's the difference. So 4 minus 6i, that would be both, because it satisfies both these things. I have a plus bi, and we're solid. So 7, we would say, is complex, because it has a plus bi, but my b is 0 here. This is 0, so I just have the a, 7. This one we'd say is both. Okay. 0 we would say is complex. And 12 plus 3i we would say is both. So I'm just looking for that a plus bi, and I'm trying to determine when a is 0 and b is 0, and which definition it fits into. Alright, the number I. The whole thing about imaginary numbers. The reason we have imaginary numbers is because we have negative exponents. Okay, so it's what we did to be able to deal with and simplify these negative exponents. So right now I have, so what we get is I equals the square root of -1. And then that gives me I squared, gives me -1. I to the third power, so this is the same thing as saying the square root of -1 times the square root of -1, right? Which we say simplifies to be -1. The square roots cancel out. They cancel each other out. And then we get I cubed equals I squared times I. So we know I squared is -1, and we know I is the square root of -1, which gives me negative square root of -1. Okay. We also talk about this as -I. It's the other way we talk about it. I to the fourth is 1, so that's I squared times I squared, or -1 times -1, which is a positive 1. Then it just starts all back over. So really, if you can memorize these 4, you can figure out any I to any root, because it's just those 4 in that pattern. Let me show you what I'm talking about. So to find the numeric value of 7, so I have I 7 times 5, 6, 7. So for every 4 that's equal to 1, I have 3 left over right? That's 1 times I to the third, which we just say is a negative I. Another way you can think of this is we can take 10, so I'm taking this exponent, divide it by 4, so it goes in 2 times with a remainder of 2, right? 4 times 2 is 8. There's my remainder. So I know that it's I to the 4th 2 times I squared. So I know that is 1 times negative 1, which is a negative 1. So let's do that again. So I to the 15th, I'm going to go 15 divided by 4. We get 3. 4 times 3 is 12. 15 minus 12 is 3. So I get a remainder of 3. So I know this is going to be I to the 3rd power here, which we say is negative I. I to the 36. So I divide 36 by 4. That goes in 9 times with no remainder. So I know this is equal to 1. See how we did that? We're just finding that group of 4. Okay, so finding the roots with I. So simplify the following radical. Well, what we can do is we know that we can split radicals as long as they're both under a square root, right? They're both under a radical. So what I'm going to do is I'm going to say this square root of negative 36. I'm going to put it, and I'm going to change it to be the square root of negative 1 times the square root of 36. So I'm just going to take out that negative. We know how to deal with it now. Next, I know that this 36, the square root of 36 is 6, and the square root of negative 1 is I. So I can say this is 6I. And there's my answer. All right, now you try. I want you to pause the video, try these problems out. All right, square root of negative 3, we're going to split up to be the square root of negative 1 times the square root of 3. So we would just say this is I square root of 3. I can't simplify 3 at all. Square root of negative 25, square root of negative 1 times square root of 25, which gives me 5I. All right, negative 8. We have the square root of negative 1 times the square root of 8. 8 we can break down to be 4 times 2. 4 is 2 and 2. 1, 2 comes out. So I know I have 2. Square root of negative 1 is I. I still have that guy stuck under the radical, square root of 2. So I have 2I square roots of 2. Now writing a complex number. So we want to write negative, the square root of negative 49 plus square root of as a complex number in the form of a plus bi. Okay, so we're just going to break these down. Square root of negative 49 plus square root of 9. Okay, so I know I can break this up as square root of negative 1 times the square root of 49 plus the square root of 9. So on the left here we get 49 is 7 times 7. So I get 7i plus 3. To write it in that form, I'd say 3 plus 7i. And there is my answer. You try now. Pause the video. Give it a try. Okay. Square root of negative 81 plus square root of 3. We get negative, oh, not negative I. Goodness gracious. We get square root of negative 1 times the square root of 81 plus the square root of 3, which gives me I times 9 plus, can't simplify the square root of 3, so I would just write this as the square root of 3, that's my a value, plus 9i. There we go. Okay, so here's just my review of mathematical properties. I have the commutative property, meaning addition in different orders. Multiplication, we have our associative property, talking about parentheses, associative property of multiplication, and my distributive properties. You've gone through all of these before. This is just a little reminder. If you want to take a minute, look at this chart, pause the video, or look at the PowerPoint. All right, so combining complex numbers. When we're adding complex numbers, we simply take out the parentheses and combine like terms. This is just like what you've done before using like variables, or we did it with rationals in the last unit. Very same thing. With subtracting, we have to remember to distribute our negatives, and we'll look at that. Okay, so simplify the complex numbers. So here, when I'm adding them, I'm really distributing this positive, but it doesn't change anything. So we can just take out the parentheses and combine my like terms. So I have 4 and 8 gives me 12. Then I have negative 3i and I. So negative 3i plus I gives me a negative 2i. We're good. Now with this negative, I need to make sure that I distribute that negative. So I have 6 plus x minus 11 plus x. What a lot of people do is they forget to distribute this second point right here, and they'll just say it's minus 11 minus x, and that's definitely not right. So we have 6 minus 11 gives me a negative 5. X plus x gives me 2x. There's my answer. All right, so multiplying complex numbers, we use the distributive property and the FOIL method to multiply complex numbers. I think I'm actually going to use the tabular method, that little box method. I think it will help quite a bit. All right, so multiply 2i minus 3 times 4i plus 7. So I have 2i minus 3 and 4i plus 7. So this box is 2i times 4i, which gives me 8i squared. We have negative 3 times 4i here, so which gives me negative 12i. We're just going to kind of go around the box here. Negative 3 times 7 gives me a negative 21. And then we have 2i times 7, which gives me 14i. So what we know now is that I have 8i squared. My diagonals are going to add up, so these two boxes combine together. Negative 12i plus 14i gives me a 2i and minus 21. So what we get here is we have 8i squared plus 2i minus 21. But we learned today that I squared equals something. We learned that I squared equals negative 1. So now we have to factor that in, or we have to take that into account. 8 times negative 1 gives me a negative 8 plus 2i minus 21. And now I can combine these, and I get negative 29 plus 2i. There we go. All right, you try it now. All right, so you should have 3 minus 2i and 5 plus 4i. We get 15. We get negative 10i. We get negative 8i, and we get plus 12i there. So I get 15 plus 2i. Oh, this is negative 8i squared. Negative 8i squared. So we get 15 plus 2i minus 8. I'm going to change that I squared to a negative 1 because we know that already. Okay, now we can simplify. 15 plus 2i plus 9, which gives me 15 plus 9 is 24 plus 2i. All right. So dividing complex numbers. So dividing complex numbers is very different from dividing other polynomials or numbers, okay? So we really should call it getting the I out of the denominator. In mathematical, I guess, making it acceptable is we don't like to have a square root in the denominator. So we have to find what's called the conjugate of the denominator. Then we multiply the numerator and denominator by that conjugate. The conjugate is the same expression, but the sign changes in between. I'll show you what I mean. And then we have to simplify it. Okay, so we looked at my denominator. I have 7 minus I. The conjugate of this is going to be 7 plus I, because what's going to happen is it's going to get rid of that I term. Then I have 7, but I have to do it by the top and the bottom. So what I get is we have to use the FOIL method here. So I get 21 plus 3i, and then 4i times 7 gives me plus 28i plus 4i squared. Now I have to do divided by the bottom. We get 49 plus 7i minus 7i minus I squared. Now we have to simplify all this. So I have 21. I can combine these middle terms. We get 28 plus, we get plus 31i plus 4 times I squared we know is negative 1, all divided by 49. But look what happens here. These terms right here cancel out. I'm left with a negative. I squared we know is negative 1. Next we can say 21, and we're going to combine this negative 4 right here. So 21 and negative 4 would be, let's see, 18, right? No, 18, 19, 21, so it'd be 17. 17 plus 31i. Then 49 minus negative 1 is 50. Okay. Now I would like you to try to perform this one. If you need, so pause the video real quick and try it out. Okay, so we have to multiply by the conjugate here. Okay, so what we're going to do is we're going to look at, well, what's my conjugate? Well, that's going to be, oh, show's not over yet, 2 minus 4i. Okay, so we're going to multiply that by top and bottom. Next, we need to multiply this, distribute this out. So I get 3i times 2 gives me 6i. 3i times a negative 4i gives me negative 12i squared, divided by 2 times 2 is 4. 2 times the negative 4i is negative 8i. 4i times 2 is a positive 8i. And 4i times negative 4 is negative 16i squared. Okay, now we can simplify this stuff. We get 6i minus 12 times negative 1. And then we get 4. My middle terms cancel out. Minus 16 times negative 1. Next, we get 6i plus 12. And we get 4 plus 16, which we can now say is 6i plus 12 divided by 20. There's my answer. So hopefully that wasn't too complex. We just added that I into it, which makes it a little bit different. If you have any questions, please come and talk to me. We'd be happy to help you out. Thanks. Have a great day, too.